Hey everyone, and welcome back to our Learn to Code 1 series. And today we're going to be tackling a new concept, logical operators. So you've got conditionals, your code can make decisions, but what happens when you need to check multiple things at once? In this episode, we're diving into logical operators, things like and, or, and not, that let your code combine conditions to get even smarter. So want to collect a gem and toggle a switch? Only move if there's no wall ahead? This is where those decisions come together, and your logic starts to level up. Let's break it down and walk through it together in Swift Playgrounds. So we're starting off with our slideshow here. Could you be more specific? Earlier, we used an if statement to plan for different situations, but what if we could make your conditional code even more powerful, right? If the light is green, move forward, else when it's yellow or red, we're going to go ahead and wait. In code, an operator is a symbol which represents an action. So we have things like the equal sign, we could even do math with that, the addition sign to add two things together, and the new symbol here, the double ampersand, or shift 7 on your keyboard, represents the and symbol. A logical operator is a type of operator that we can use to make our conditional code a lot more specific. So again, we have the and, the double ampersand, the or, which are those two lines. If you're using a keyboard, it's the straight line. It should be the key right above your return key. And the not is actually represented by the exclamation point. So the logical and operator only runs if all conditions are true. So if blocked and on a gem, go ahead and run that code. So both these conditions must be true. The logical operator or, this runs at least one of those conditions is true. If on a gem or on a switch, do a dance. So again, it's those two vertical lines. And the not operator changes the condition to its opposite. This is great because we have true and false. So the opposite of true is false and the opposite of false is true. So if you are not blocked, it is basically what this is saying, then you can fly away. Let's go ahead and start coding. All right, our goal is to use the not operator, so the exclamation point, to adjust our character's path when there's no gem on a tile. So as we learned before, the logical operator, exclamation point, changes the value of a Boolean to the opposite, essentially inverting the value. It also wants us to run the puzzle a few times. Notice that there are always 4 gems, but one is at the bottom of the stairway here. When there's no gem on top of the platform, the stairs extend to that tile. Okay. And we're going to use the exclamation point to determine when our character is not on a gem. If not on a gem, turn and collect the gem at the end of the stairs. Otherwise, collect the gem. Okay, sounds pretty good. Okay, let's go ahead and add our if statement to check for the conditionals. So if, then we're going to look to check to see if we're on a gem. But remember, we want to look for the opposite. We want to say if we're not on a gem in this case. We're going to use the exclamation point in front of is on gem. Let's go ahead and check how we can handle this situation. So what logic should we put here? Remember, we need to navigate down here and collect the gem that will be at the bottom of the stairs. So we need to turn left, move forward a couple times, right? Because we got to get down the stairs and to where the gem is. Would then want to collect the gem, turn back around, move forward twice again to get back on this upper level. And then we'll want to turn left to resume our journey. We also need to handle the case of when we're on the gem and we need to collect it. So let's add an else statement, our brace, and we'd want to then just collect the actual gem. Okay, let's go ahead and run through our code and see if that's what we needed to do. I'm going to step through our code, move forward. We're going to collect the gem, move forward. We're on the gem, so we're going to keep going. Move forward. We're not on a gem, so we need to turn left, move forward twice, collect the gem, turn back around, move forward, then turn left. And you're going to collect that last gem. Pretty cool. So by using the not operator, we were able to handle those conditions very, very well. So we're reversing that Boolean value. So when we're not on a gem, do this. Otherwise, we're on the gem, let's collect it. Okay, let's go ahead and head on to the next page, spiral of not. We have another loop here that we need to use. puzzle world and this challenge is slightly different each time we run it. Try to figure out how to use the logical not operator to solve it. The condition is blocked is either true or false, which gives us a Boolean value. If you can't move forward one tile in the current direction, is blocked is true. If you can move forward, is blocked is false. So we need to be able to determine if we're blocked. If we are, we need to handle that situation appropriately. Let's go ahead and run the code and see if the world changes. Okay, so we can see that this almost spiral pattern is changing every single time that we run the playground. So let's think about this logically. So essentially, if we are not blocked, we want to move forward. And it looks like at the end of all of these, we should be able to just turn left to continue the playground. So let's create an if statement within our loop here. And we'll look for the condition of the opposite of is blocked. So when we're not blocked, we should be able to just move forward and be on our way. In the case that we are blocked, let's add our else statement, add our brace. We'll then want to turn left, right? We determined that when we can no longer move, to get through this spiral pattern, we need to adjust our character left. We'll then need to toggle the switch at the very end. I assume we're going through this 13 times. We'll then want to toggle the switch. We could also have a condition that checks if we're on the switch and toggle it when we need to. Go ahead and step through our code. We get a new puzzle to deal with. We're going to be moving forward. I am using the conditions on the left side here so we can track and just kind of bouncing forward because we're saying, hey, we're not blocked, so let's move forward. And let's see what happens when we finally do get blocked on this sand tile by the water here. Okay, so we're blocked here, we're going to do the else, we're going to turn left. Great, we're going to check, are we blocked? Nope. Let's move forward a few more times. I'm going to turn left. Here we go. Oh my goodness, we didn't have enough spaces. So I guess when we regenerate this kind of sequence every single time, there's a different amount of tiles. Oh no. All right, let's set this to be a higher number. So we were missing 1, 2. So let's just do 15 and hopefully that's enough. What if it gives me a 16 tile one next time? Okay, let's run this faster now that we know our logic works. Look at him, he is absolutely zooming. See, did it actually give me a 16 tile one? Oh my, you know, maybe I'll make it 20 just so we can handle all these things. If you run into the same issue, just make your for loop a little bit higher and you should be good to go. That's pretty funny. All right, so by using the logical not operator with a condition of is blocked, we always know when our character is not blocked, so we can continue with the puzzle. And when we did encounter that roadblock, we just simply turned and continued on with the puzzle. All right, let's head on over to checking this and that. All right, we have a line of gems, some switches on the side, one toggled, 3 of them currently not. So we're going to actually use the AND operator to combine 2 conditions to adjust our path if both are true. So that double ampersand combines the 2 Boolean conditions and run your code only if both are true. So both of those values need to be true. So for this example here, is blocked and is closed switch must both be true for this code to run. We also got a new condition, is blocked left is true. We can't move one tile to the left. We now have something that checks if to the left of us is blocked. And we have a for loop that goes through 7 times. And we're starting off by moving forward. We'll then want to create our if statement, and we're going to be checking for 2 things. Well, it's giving us the is blocked left, and we can see here that we have some blocks here. And every time there's a block on the left of our character, we'll want to move over and toggle the switch. Let's go ahead and add our if statement. And we're going to look for if they're on the gem. So is on gem. We have tons of gems here. Then we're going to use our double ampersand. And we're going to be checking if we are blocked on the left. So is blocked left. Then we'll want to write some code. If the case is where we're blocked on left here, when we also have the gem available, right? We can see it happens at least 3 times here. We'll want to collect the gem. We want to collect all those gems for Byte. We'll then want to turn right and make sure that we're toggling the switch. Let's go ahead and turn right. Move forward 2 times. Toggle the switch. Let's turn around with 2 turn lefts. We'll then want to kind of return with our move forwards. Then we'll turn right, so we're back on this vertical row path. And we should be pretty good. But what happens when we're on a gem and we need to collect it, but we're not being blocked left? We can see there's a gem in front of us, the one by the lily pad and by the waterfall. They're actually not blocked on the left. We should create an else if statement to say, okay, if we're on a gem, even if we're not blocked left, we still want to collect it. Let's do an else if statement and say, else if we're on the gem, we'll then want to collect gem. Okay, and this should loop through the playground with our logic, collecting the gems even when we're not blocked left. And in the cases we're on gems and we are blocked left, we'll go ahead and toggle those switches. Go ahead and step through our code and see if we got it right. Then move forward, collecting the gem, right? We're always looking to see if both of those conditions are met. This case, neither of them are met. So we're just going to go ahead and move back to moving forward. This one, we're on the gem, but nothing to our left. Collect it. Okay, and now we're saying, hey, we're on a gem and we're being blocked left. Collect the gem. We're going to go over here, toggle our switch, turn around, move forward, turn right to get back on the path. There we go. All right, we're moving forward. We're on a gem, but we're not blocked left. So we're just going to go to our single on gem. And here on the gem, block left, we're going to go ahead and repeat that loop a couple times. Toggle it, turn around. We're pros at this already. Turn right. We're going to go through a loop again, move forward first. We'll go ahead and run that code, and we should be good to go. Look at that. So we've combined multiple conditions to check whether all are true before running the block of code. Now it's time to use our OR operator. Take a look at our puzzle here. Interesting. We have some walls, we have a teleporter, we have a gem that's behind some walls. This looks pretty crazy, but we can use the OR operator to solve this puzzle. The OR combines two Boolean values and runs if at least one is true. So when we had the AND, both had to be true. With OR, only one of them has to be true. So on either side of those lines, as long as one of those is true, the code will still run. So for example, if is on gem, or is blocked left, move forward. And both can be true and it would still run, but if neither is true, it won't run at all. As a hint, you may be blocked in either from the front or from the left. Okay, let's go ahead and add our if statement. We're definitely using conditions here. So we're gonna look for is blocked. We're gonna add a space here, and we're gonna add our double lines either from the autofill or from the straight line above the return on our keyboard. I'm just gonna use the autofill just to make sure we have it exactly right. And then let's see what else we can look for. It looks like on gem, open switch. We can use our is blocked left again to check for when there's something blocking us in the front or to the left of our character. So if that's the case, what would we need to do? All right, so let's think about this. Let's say Byte moves forward. He's being blocked in front of him. Well, he would need to then turn right. Let's have them turn right. Then what? Well, they should probably move forward, okay? And then they'll move forward again. They're going to check for the block condition. We're being blocked on the left. So he'll turn right and go through our teleporter. So let's have a turn right and move forward. We also need to handle the case of when they're not blocked, because in my scenario I just gave, how did he get to this other second pillar? Well, we can use an else. And in the case that he's not blocked, we can have them move forward. Okay, let's go ahead and run our code and see how this works. So in the case of when they're blocked in front or to the left, they're going to try to turn right and then move forward. When they're not being blocked, so in between these two pillars here, they should just be moving forward. All right, let's go ahead and run our code. So in this case, Byte is currently not blocked. They're going to just move forward. Now they're being blocked in front of them. They're going to turn right, move forward. In this situation, not blocked to the left or in front. Just going to move forward. Now we're being blocked on the left side. So we're going to turn right, move forward. That puts us through our teleporter. We're going to check. Are we blocked to the left? Nope, not forward. Move again. Looks like we're pretty much good to go. And in this case, we do have this pillar to our left. So it's totally being blocked. We're going to turn right, move forward. We should get to this pillar with these brown stones on it. We're going to do our is blocked. Move forward, nothing in front of us. Just gonna rotate the camera and we can see we're being blocked on the left again. Turn. There we go. We're being blocked in front. Look at that. The only thing is, we forgot to put the collect gem. No. Okay, so we know that we go through this 12 times, and assuming, unlike the other thing, it doesn't actually change what we're dealing with, let's go ahead and add the collect gem. Okay, it looks like the terrain doesn't change. So let's go ahead and just move fastest through this. We already kind of know that our logic works. We just forgot the collect gem, which is totally fine. We just wanted to check to make sure it worked first. So great job. We know how to use all of these different logical operators, the not using the exclamation point, the ampersand for and the double lines for or. We can be very specific with how our code runs. And if I had to guess, in this next puzzle, logical labyrinth, oh yeah, we're using all three operators to really test out our skills. I know for a fact we've got this. Okay, so we have a for loop going through 8 times, and we're starting off with a move forward. We'll then need to use our logical operators in order to solve the puzzle. So let's take a quick look at what we got here. We do have a puzzle. We have some gems, we have some switches, some walls. The first thing I want to test for, honestly, is to see if the terrain changes on the playthrough. Okay, I'm just going to run through it again. Okay, it looks like the terrain does stay the same. So I'm just going to reset Byte back to where they start. Now we know the switches, the gems, they don't change. Good to know. So the first thing we should do is add our if statement, and let's think of what we want to account for. I think if we're on a gem and on a closed switch, you know, this happens a few times, right in front of us, down these stairs, and to the left here. Maybe we can track to see if we're on the gem and on the closed switch, that we can handle maybe a pattern. Because look, every time there's a gem on the closed switch, also to the right of it and 2 tiles forward, there's a gem. See, right over here, we'd have to turn our character right, grab the gem, and over here as well, turn our character right and grab the gem. So there's a pattern there. So let's go ahead and handle that condition first. So if we're on a gem and we're on a closed switch, we need to write some code. So the first thing I would do is collect the gem and toggle the switch, so we don't have to worry about that. Then we should turn our character right, move forward a couple times. Right, we need to get to that gem there. Let's then collect the gem, turn our character back around. You can either do 2 turn rights or two turn lefts, and then need to move forward to get back to that starting switch, which we've already toggled, and we've already collected that gem. So then let's turn our character right so they can continue on their path. That should work. Let's go ahead and test it out real quick. So we're going to move forward. Both those conditions are true. We're going to collect it, toggle it, turn right, move forward, collect our gem, turn back around, forward again, turn right, and we can continue on our journey. Now I'm going to stop it here because we haven't handled the condition for when we're just on a closed switch without a gem, or the condition when it's just the gem on its own. So let's go ahead and handle those now. So at the end of our if statement, we're going to go to this brace, and you can always kind of hover over the if statement to see where you are, especially with those nested statements. And we'll add an else if. Just going to add a little space there. So let's handle the condition. Byte's currently on a closed switch, so else if is on closed switch. We should go ahead and toggle the switch. And it looks like every time we're on the switch, we'll also need to turn our character, in this case left, and I believe left here as well. So let's do a turn left. Okay, great. And then let's also handle the condition of else if we're on just a solo gem. So we can see right here, this gem's just hanging out on its own. Else if is on gem, at our brace, and we'll collect the gem. We shouldn't need to turn. We'll just go back to the very start of our for loop and move forward. So this should handle all of our conditions. Let's go ahead and see if we got this right. So we're going to move forward. We're on that gem and closed switch. We already know this one works. Awesome. Do our turnaround. And you can even make the function for turnaround, right? If you really wanted to. Okay, and here we go. So now we're on a closed switch. So we're going to toggle it, turn left, Great. We're going to move forward. Nothing's true, so we're just going to go ahead and move forward again. All right, and we have that gem and close switch situation. Grab it, toggle. Grab the gem on the side path. Turn back around. Great. Turn right. We're going to move forward. We're definitely on a close switch. Let's go ahead and toggle it. It didn't do the jump. Okay. Move forward. Okay, we're just on the gem. We're going to collect the gem. Okay, we're going to move forward again. It's that situation where both are true. We're going to collect, toggle, and go grab the side path gem. I think we did it. I think we solved the logical labyrinth using the for loop. But to be fair, I actually didn't use the not operator. Maybe you found a solution where you used the not operator. It even says solve the challenge by choosing the operators and conditions that will work best, but you might find a different solution than I did. So congratulations, we have done it. So it wants us to celebrate our hard work by throwing our hands in the air and yelling, I did it. I'm not a very loud person, so I'm not going to yell that. But you might want to if you're in a space where you can do so. So now our code can check for everything it needs to before taking action. That's the power of logical operators. In the next episode, we're going to be talking about conditions and loops a little bit more in depth with while loops. You can think of it while a condition is true or while a condition is false. We'll use those logical operators. It's all coming together in order to repeat code. So until then, drop a like if this helped, subscribe to keep learning, and keep building those coding muscles. You're doing great. Dream big, code bigger, and we'll see you in the next one.